Okay, figure out how to do this here. Okay, goes on. Oh, we're gonna have normal latency. Bummer. People's questions are gonna take longer to answer. Let's create material. Two. File. I can answer questions from the homework. Okay, I could answer questions from the homework, I guess. Wonder how to do this, maybe full screen, and then just. Hi, Marcia. If you have any questions over the homework, feel free to ask them now. I didn't make a video explaining the last homework. I figured it was more clear, but this next one, I'll definitely do. Okay, so we're going to go over 12.2. Let's go even more. Control plus. There we go. That's better. Even though it's still tiny letters. Okay, so this one's just going to be graphing this section. It's just graphing rational functions, which we've been doing. Inverse functions are rational functions. But for the sake of simplicity, all this really is just vertical shrink, stretch, or vertical or horizontal, what is it called? Translation or reflection. So it's really all those. Number 2C and 1A. Okay, I'll explain those two just because we have a few people on. Oops, below. Okay, sorry, 1 second. I don't know what just happened. I guess I do know what just happened. Let's see, history. There we go. Okay. Okay. Let's open. I'll open. Homework. Okay. This one. Okay. Hi, Ezra. Okay, so you said 2C and 1A. Well, 1A is going to be, I thought this was a good marker, but I am getting second. Doubts about that, so we'll try this one. Okay, that one. So 1A is, we'll have 2K minus 11, and this is squared, which means we just write 2K minus 11 times 2K minus 11. Now you just multiply this times FOIL. So what you're going to do is you're going to just do first times first, so 2K times 2K, and outside, so plus 2K times negative 11. Then again, inside, so negative 11 times 2K. And then last, which is negative 11 times negative 11. And these two should be able to be combined. Hi, Jackson. So I'm just explaining 1a. So this is 1a from the homework. Okay. Okay, so that's 1a right here. You can do the math from this point on. Okay. I believe in you guys' abilities. So from this point on, you'll be able to do it. Okay? Okay, and then 2c. How long should tables be? It's a great question. Okay, 2c, 2y equals 8 over x. What we want is we want only the numbers to be here. Yes, you could have distributed the squares. I'll talk about how long tables should be, Marsha, in just a moment. So first we just divide both sides by 2. Divide by 2. That's going to cancel this. This is going to be a 4. This is going to be 1. So y equals 4 over x. And we know that this is in the format of one of the variations. Okay, it's a very clear variation. So you should be able to see. Okay, for tables, what I want is I want the same number of negatives as positives. Okay, so if you have 2 negatives, you're going to have 2 positives. Now, preferably you have 3 negatives, 3 positives, so that you can see how the graph, you have to draw the graph. So I'll show you what I kind of want for these tables, okay? Okay, so that's 2c. Now, if you have other questions on the homework, you may write it in the chat. Otherwise, we're going to go straight on to the book. Okay, 12.2. Rational functions. We already talked about the first function, inverse function, which is y equals 1 over x. And if you remember, this graph should look something, should look something like this. Okay. Okay, it should look something like this. Now, domain and range. So domain and range, you would just say that the domain x does not equal 0 because x can't equal 0 right here, and y doesn't equal 0. Essentially, you can't make this, you can't make it so that 0's here or 0's here. Okay, that's just part of the rules. Okay, I'll go to 3b in a moment. Okay, yeah, so this is inverse variation. So, now, Jackson, I'll answer this question through the notes of this section, okay? If you have questions at the end, just feel free to ask it again, okay? So, vertical asymptote is this, that line we can't cross, and horizontal is this line we can't cross. Okay? We're going to draw, now, we're going to be in these rational functions. Rational just means a ratio of 2 functions. It's basically there's division involved. Okay, so we're going to draw y equals negative 2 over x and y equals 1 over 3x. Okay, now all these both are the function y equals a over x, where a is some number that's not 0. Okay, it can be any number besides 0. It can be negative 0.5, negative 3, positive 10, whatever, doesn't matter. Okay? Okay, so how to do this table? Well, first you need to remember that the only 2 numbers this can't be, well, that x can't be 0 and y can't be 0. That's the only thing. So if x can't be 0, that's going to be the, center. So if we put 0 here, -1, -2, and -3, and we do 1, 2, 3. Okay? 0 is our center. Do you have to do this every time? No, you don't. You don't have to put this point. But the point is you need to know that there's going to be an x value we can't put in. Okay? There is going to be an x value and there's going to be a y value. That won't work. Okay? So -3, if we plug -3 in for this function right here, we get 2 over 3. If we plug in -2, we get 1, because -2 over -2. Plug -1 in, we get 2. So this is undefined. Then this is -2, -1, and -2 over 3. Okay? It's because the top is negative and the bottom is positive, then that's going to be a negative number. So if we're drawing this is going to be a really small graph because it just shows space. So I'm going to have the middle here. 1, 2. Sorry, I'm going to break up the 1 into smaller pieces so I can just keep track of this. 1, 2, 3. 1, 2, 3. So this is -1, -2, -3, 1, 2, and 3. So anyway, -3 correlates with 2 over 3. -2 correlates with 1. And -1 correlates with 2. So we're actually going to have this graph right here. Okay? Now, this graph would go like this. And this, same thing. 2, 1, and so you'd get a graph like this. Okay? So just like that, okay? You plot your points and you graph you draw a line through them. Yes, you can use -4 and 4. So these numbers don't have to be these same things. But I would always suggest -1 and 1. I always suggest it. That's the easiest thing in the world. Okay? Almost always the best choice. Like there's rarely a time you don't want to plug in 1 for x. Okay? So how would that work with this right here? This 1 over 3x. Okay? So this is a negative. Now guys, what does a negative do to our graph? What kind of transformation is it? Well, this would be reflection. Okay? Reflection. And 2, this 2, the absolute value of a is bigger than 1. So this is a vertical stretch. Okay? So it's a reflection because there's a negative. A is less than 0. It's a reflection. And because the absolute value of a is greater than 1, we have a vertical stretch. Okay? So, what is our a here? Well, this is the tricky one. A here is actually equal to 1/3. So since a is 1/3, it's not negative, and the absolute value of a is less than 1, we have a vertical shrink. Okay? We have a vertical shrink. Okay? Let's just blow that up a little bit. Okay? Now let's draw this out. Okay, I'm going to use the same table. You can use other tables, but it's preferable. Okay, -3, -2, -1, 0, 1, 2, and 3. So I plug in -3, I get -1/9. Plug in -2, I get -1/6. I plug in -1, I get -1/3. So see, all of these are smaller. So if you get to work, no, it's just the table. Just the table. table use work. Okay, and then 0 is obviously undefined because 3 times 0 is 0, and then we can't have that. So 1 is going to be 1/3, 1/6, 1/9. Now people, if you really didn't want fractions here, then our x values would have to have been fractions. Okay, that's the tricky part. So if you didn't want it, like, let me show you an example. What if x was, let's say 1/3. If x is 1/3, then y equals 1/3 times 1/3, which would equal y equals 1/1, y equals 1. Okay? So really, we would have had to use fractions here if we wanted our y values to be anything. So the difficulty is you're going to have to deal with fractions at some point. Okay? So with this, draw it. Now, for the sake of our y, we're actually going to do like a 1 right here. This is going to be a 1. Now, did I kind of zoom into our graph a little bit? Yes. So I'm going to break this into let's do thirds. And then this has a third. Yeah, that's fair enough. Okay. Was it 1? Just to, illustrate kind of zoomed in nature here. 1, 2, 3. This is a little more stretched out. 1, 2, 3. Okay, and so at 1, 2, 3, -1, -2, -3. So at -3, we're at 1/9, which is right here. At -2, we're at 1/6, which is right here. And 1, we're right here. And actually, if you wanted to do another point, we could do -1/2, -1/3, which would be right here. So and if I did the same thing here, 1/3, 1/3, this is 1/6, this is 1/9. Now, the reason why I chose to draw 4 points is just because I wanted to show the curve goes back up. Okay. Yeah, I preferred whole numbers in our y, but really it doesn't matter. Honestly, it's better you get the concept of just one of these is going to have to be a fraction. Okay. Either our x is fractions or our y is fractions, and you kind of have to decide. There are easier ways of doing the table, so if you're curious about that, there's easier ways. Okay. So if you notice on our graph on the book, it really goes close to our 0, and actually that's what vertical shrinks will do. Our vertical stretch will push it away from 0, 0. Okay. Oh wow, that's blurry. Okay, well the book is blurry over here. Okay, so now if you remember from last section, we had this. I'm going to show you what we had before. We had a square root of x minus h plus k. And if you remember, a was either reflection, vertical stretch, or a vertical shrink. Okay? H was our horizontal translation. And K was our vertical translation. Okay? So if you remember this, these three are going to stay the same. They're the same for us, okay? What do I mean? Well, our new drawing, our new formula is going to be this. Y equals A x minus h plus k. Okay? X minus h plus k. So at h is going to be horizontal translation. K is going to be vertical translation. So whether we move up or down, it's going to be left or right. And this is going to be taller or wider. And this is going to flip it. So from here to over here. Okay? It flips it. Okay? So these all are going to stay the same for this. And that's the whole lesson, is basically using these different things. In fact, actually, that is the whole lesson. Will we have fewer graphing assignments today? Yes. Will we need to know the key concepts? Absolutely. Okay? Okay. So, we're going to use this, but these two are going to mean something more than just translations, okay? They're going to actually mean more. Okay, so let's try a graph. Okay, if you ever need to pause and write it down, feel free to, or comment. No, I could stop for a second. Okay, y equals 1 over x plus 3. So this 3 right here is going to be a vertical translation. It's going to be a vertical translation. And what it's going to do is also, this k, y equals k, is our horizontal asymptote. And asymptote just means we're not passing that line. Okay, we're not crossing that. So if I have a graph, I know some people who are going to watch this later may have questions. If you have questions on any of these videos, feel free to ask me. Sorry, we're going to... Actually, you know what? Let's start with making the table, because that will help you. Okay. Okay. So our table, let's just do x and y. Negative. They do -2, -1, negative 0.5, 0, 0.5. Why'd they choose 0.5? Because it's kind of easy. Kind of easier. Okay. So -2, you plug it in, you get -1/2 plus 3, so this becomes 2.5. -1 becomes 2, and -0.5 becomes 1. This is undefined. 0.5, if you divide 1 by 0.5, you get 2, so this is 5. And this is going to be 4. And it's going to be 3.5. If you have questions, you can do the math. Okay. So I'm going to actually make our graph so that there's more happening above the axis than there is below, because we are obviously dealing with more above things than below things. Here we go. Here we go. So this is 5. It's 4, 3, 2, 1. Okay. Now our vertical asymptote is y equals 3. Okay, that's our vertical asymptote. That's one of the things. And you will make a dotted line at that point. Okay? Dotted line at our horizontal asymptote. Sorry, vertical and horizontal. In this case, our horizontal is just x equals 0, which is this line up and down. Okay, then we plot our points. Sorry, let's respect this one. So we have 1 and 1/2, 2. So 2 we'll go with 2.5, which would be right here. 1 would go with 2, and 1/2 would go with 1. So actually, our graph will look something like this. Okay, over here, this is 1, so this is, sorry, negative 1, and negative 2. Yeah, that's more accurate. Okay, and then this one is 2 right here, so 1/2 goes with 5, then 1 goes with 4, then 2 goes with 1/2. So again, our graph looks like this. Okay? Okay. So we have our vertical asymptote. So vertical asymptote and horizontal asymptote. Okay, vertical asymptote and horizontal asymptote. Okay, and all you have to say is this a vertical translation right here. It's a vertical translation. Okay. Okay. What can our domain be? Our domain's all numbers besides 0. So domain is x does not equal 0, and our range is well, y can't equal 3 because there's no number here. So y cannot equal 3. So notice our vertical asymptote is what's here. Horizontal is what correlates with here. Okay? So we're going to go into, let's do one practice problem. Let's do a practice problem. Okay. Practice problem, and then we'll go into the next one. Then we'll do the whole compound graph, and we'll be done. Okay, compound graph. So we do one more vertical translation example, then we do a horizontal translation, then we do asymptote. So asymptotes, the secret is horizontal is whenever this bottom here equals 0. So whatever the work is, when the bottom equals 0, that's your vertical. Okay, vertical is denominator equal to 0. Okay, set it equal to 0 and then solve it. The horizontal is whatever you're adding. So if we have some number k here, it's k equals whatever k equals is our k equals y is our horizontal. Asymptote. Okay? Okay. Let's do a practice problem. Got a song stuck in my head. Clearly, I was planning on having a song stuck in my head on this beautiful day. Okay, so let's graph this. Graph. We need domain range. And we need to compare. Okay? So those are 3 things we're doing. We're graphing, we're finding domain and range, and we're comparing. Okay? Okay. So let's Load this up. It. Okay. So we'll just have that. Okay, we're going to work through this one. So, how do we do this? We start with our table. Our table here, honestly, it doesn't matter how you do this table, but I'm going to show you, in this case, you want to show that how the curve works. So normally I would say -3, -2, -1. This one I'm going to do -2, -1, and -0.5. Now the reason why we use this is because this is going to change how we do it. Okay, 0.5, 1, and 2. Okay, and so with this one, I'm going to plug in -2. That's going to get -1/2. So we're going to get -4.5. This is going to be -5 and -6. If you do the math, -0.5 from here is going to give us 2. Okay, that's going to be -2 minus 4, -6. This is going to be -2, -3, and -3.5. Now there's a pattern here if you notice. Opposite sides are going to be the same distance from our asymptote. Now for this one, we're mostly in the negatives, or we are all in the negatives. So we're just going to do that. -1, -2, -3, -4, -5, -6. -5, -4, 3, -2, -1. Yeah, this is, so we're going to do 0.5, 1, 1, and 5, 2. 0.5, -1, 0.5, -2. Okay, this is going to be slightly warp our graph, but it won't be. You could -4, -2, -1. Yeah, you can use that. That's not a big deal. Okay, you do want to show the curve. So Ezra, if it doesn't show that the graph is curving, then you're gonna have a problem. Now, where is our asymptote? Our asymptote is this number equals y. So y equals -4. So our horizontal asymptote is going to be a dotted line right here. And the reason why we make a dotted line, is so that we don't cross it, okay? So we know our graph can't cross this line, okay, in inverse functions. Okay, so inverse functions is not going to cross the line. Now there are exceptions, but let's just say we don't deal with our exceptions, okay? Okay, so 2 goes with 3.5, so give myself a 3.5. That's roughly there, okay. 3.5, -1 with 3, then 1/2 with this. So if you see, this is curving, you're going to want to have this kind of shape, okay? You want to have this shape. Same thing over here, 1/2 is going to give us -1/2 is going to give us -6, -1 is going to give us 5, and then -2 is going to give us -4.5. So you want to notice something. As we go further along the x-axis, bigger and bigger numbers, we should get closer to our horizontal asymptote. As we get closer to the middle, we should get further and further away from our horizontal asymptote. Okay, so what's our domain and range? Okay, domain is what number x cannot be. What number can x right here not be? X cannot be 0. Can't have a 0 on the bottom. Y can't equal k, so y does not equal -4. Now this right here is our asymptote. Okay? This is our asymptote for y, and this is our asymptote for x. Okay? Okay, so domain and range right here. We needed that. We needed this graph. And then last thing is compare it. So what did this -4 do? Well, this was a vertical translation. Okay? And that's all you do. Vertical translation. If it's only a slight curve, it's okay. Okay. My warning with a slight curve, Esther, okay, is that if it's not clear, some people will draw a straight line. A straight line is incorrect, okay? So it must curve. A curve means it kind of turns from the direction, okay? So if it is a straight line, you've got it wrong. Okay, so make sure your table shows that it's not a straight line. And if you need to do more than 3 points to do a curve, you need to do more than 3 points on each side. Okay? Okay. Oh yeah, you had boxed this answer too. Do you have to do of the number? No, you just need to say vertical translation, horizontal translation. That's it. Okay? Okay. Laser sounds. Okay. Do we need to say, so Marsha, For this section, you don't have to say negative. Okay, you just say vertical translation. I think that, yeah. Okay, now we're going to deal with the ones where it's x minus h. Okay, so this is going to be a horizontal translation. Okay, it's going to be a horizontal translation. So x minus h. Okay, and our vertical asymptote is h equals x, or x equals h. It doesn't really matter. Okay. Okay, so vertical asymptote is going to be x equals h, which will affect our table. Okay. So an example, y equals 1 over x minus 2. For this homework, I'm actually going to post homework help videos, so I will post a quiz. Quiz won't be graded, but if you want homework help, you should fill in the quiz. I did the quizzes earlier. I thought they were a good idea, but it's also, I don't want you guys to feel overwhelmed with it. Okay, so x minus 2. So our vertical asymptote here is x equals 2. Okay, now how do you tell? What can you do? Well, the way we tell this is we actually set the denominator equal to 0. So x minus 2 equals 0. Then just solve for x, x equals 2. Okay, so this is our vertical asymptote right there. So then our table is going to have the middle 2. Okay, so to the left we're going to choose 3 points, and to the right we're going to choose 3 points. Okay, okay, and this should be undefined right here. Okay. Okay, so what do we choose to the left? Well, you can just do, so this would be 1, 0, and negative 1, 3, 4, 5. It doesn't matter. It just doesn't matter for that one. They do something else. It's not terribly important. Okay, so then this 1, if we plug it in, we get negative 1. Plug in 0, we get negative 1/2. Plug in this, we get negative 1/3. Plug in this, we get 3, we get 1. Then we get 1.5. And then we get 1. I'll just do it with fraction. We get, that does not make sense. 4, so this is 1/2. And this is 1/3. Okay, just plugging it in for x. Okay, sorry, sometimes I don't show the math it's going on in my head. So, we are going to graph this. Okay, and I think I have plenty of space right here. So, let's just graph this. And if you're wondering, I am going to make it skewed to the right. We get 1, 2, 3, 4, 5. Negative 1. Have 1. One half. Okay, that's fine. Okay, and then this is also going to be 1, 1/2. Okay, so this is negative 1, 2, 1, 2, 3, 4, 5. Okay, so we're going to have a vertical asymptote here at 2. So it's going to be up and down. Our horizontal asymptote is just going to be plus 0 right here, so plus 0, so we don't need to worry about it. And we're just going to plug in stuff. So at 1, we have negative 1. At 0, we're at 1/2. And at negative 1, we're at 1/3. 3, we're at 1. This 1 is negative 1. 3, we're at 1. 4, we're at 1/2. 5, we're at 1/3. So we're going to have this gentle curve right here going up and down. Okay? Should it be negative 1/4 when x is negative 2? Yes. Yeah, you are correct. Sorry, this is supposed to be negative 1. Yeah, it's just really messy. My apologies. Okay, so what is our change? What was the change? Our horizontal translation. Okay, what's the domain and range? So domain is affected by this h right here, this thing. So our domain is just not equal to 2. Our range is y does not equal 0. Okay? Okay? So, yeah, my apologies. Sometimes I'm messy. Or most times I'm messy. Okay, so those are our vertical and horizontal translations. Okay, vertical is horizontal translation. Okay, notice this dotted line shifted. We shifted over to this point right here. Okay, so the middle used to be over here. Now it's shifted over here. Again, we don't cross this line. We don't cross our horizontal asymptote, and we don't cross our vertical asymptote. Okay? Vertical and horizontal, we're not crossing. Okay. So, last part. Okay? We'll do our last thing, and then let's do a few practice problems because that's a good idea. Okay? A few practice problems. And then we'll be done. We'll be done with this actually pretty early. Okay. Actually, should we do one horizontal translation method? Yeah. Let's do one horizontal translation method. So y equals 1 over x plus 5. Okay? So this is our horizontal translation. Okay? Y equals 1 over x plus 5. Okay? So I want you to graph, find the domain and range, and then compare. Okay? Pretty simple exercise. It's going to be repeated several times. Okay? So, we're going to do that one. Let's translate back. Okay. Go ahead and work on this. Again, I'll just walk us through it slowly as we go. Okay? So I will be back in 30 seconds. Give you 30 seconds head start, and then I'll come back and, help you guys out. Okay, let's start going through this one. So, the graph. Okay, the graph of this function, the graph is going to be dependent on our domain and range. Now remember, our graph is a horizontal translation. Okay, that means we moved over so to find our vertical asymptote, x plus 5 equals 0, so we just set this equal to 0, and then we get x equals negative 5. So this is our vertical asymptote. Our horizontal asymptote is y equals 0, because we didn't plus anything on the outside. Okay. Oh, sorry. Okay. So I'm going to make our table. I'll make it down here so that we'll have space to draw right here. So x and y. Yeah, that's fine. Okay, our midpoint now is negative 5. So to the left and to the right of negative 5. What's to the left? You could do negative 6, negative 7, negative 8. You could do negative 4, negative 3, and negative 2. Okay, something like that. We're going to plug it in. It's negative 5. We plugged in. This becomes 0, so 1 over 0 is undefined. Negative 6, plug it in. That's negative 1, so this is negative 1. Plug in negative 7. We get negative 1/2. Plug in negative 8, we get 1/3, negative 1/3. And on this side, it's just be 1, 1/2, and 1/3. Okay. Remember, as we go further from the center, our graph should. Yep, that's absolutely right. So domain x does not equal negative 5, and our range y does not equal 0. Okay, and in our graph, if you notice, we shifted over to negative 5. So we're actually going to graph mainly in the negative here. And if you're wondering why I'm allowed to do this kind of shift, it's because I'm just keeping track of the center, but really I don't need to worry about the right side. So this is negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, 7, and negative 8. Keeps going. Okay, so we draw our dotted line at negative 5, at the x equals negative 5. We draw a dotted line. I'm just going to kind of expand the expand our 1 and negative 1 so that it's clearer. So then 1, so at negative 4, we're at 1. At negative 3, we're at 1/2. And at negative 2, we're at 1/3. At negative 6, we're at negative 1. At negative 7, we're at 1/2. And at negative, we're at 1/3. Okay. And there's your graph. Okay. Now the dotted line is crucial because you need to know where your x-axis is and your y-axis is, but you need to have a dotted asymptote to know what line you're not crossing. Okay. So again, boxing, we box this horizontal translation, box our domain and range, and then our graph we just keep there. Okay. Okay. Final point. Final point, final thing we're doing. And we will finish this in hopefully under 10 minutes. My goal is to finish this before 11. Partially because obviously I planned out our lesson to be shorter today. I like the graphing of this in the sense that all you're really looking at is the changes we've done. Oh, hey, Jade. You don't have to remove your comment after you say something. It's okay to say hi. Okay. Okay, so A is vertical stretch or vertical shrink or reflection. Okay. So A is vertical stretch or vertical shrink, or it's a reflection. H is our horizontal shift translation, our horizontal translation, left or right. This affects our domain. This affects domain. And K affects range. Domain. And this is a range. Okay, now domain, X cannot equal H, and range, Y cannot equal K. Okay? Y cannot equal K. Okay? I didn't. And then vertical asymptote. Now, why am I including asymptote when the book doesn't say you have to know this? Is because this is so important in my understanding of algebra that you actually need to remember it. And this is basically when x equals h. A horizontal asymptote. Now, I could do that. Yeah, we could do that. I know an extra credit assignment. I have a good extra credit assignment. Something that will make you learn and will be useful for later. So, I'll make up the extra credit assignment. Gotta post your grades for the test before I do that, so I don't, ruin your lives. Okay, so this is key information that you need to know. We need to remember that A is affecting the stretch or shrink of our graph. Okay? Okay. So, y equals 2 over x plus 1, and that whole thing minus 3. Okay? So, what are we doing? We're just graphing this for now. Okay? We'll talk about domain and range after. Okay? We're just graphing this. Okay? So to graph this, we need to know what can we not equal. So x can't equal 1. Okay? Can't plug 1 in here. So when we do our table, it's going to drastically influence where we're starting. So we're starting at 1. And since we have a 2 on top, we'll do 0. We'll do -1. And we could do -2. Or you could do -3. -2 is fine. And over here we do 2, 3, and 4. Okay. Now I want to tell you something we're going to notice. It's actually some information in here that if we look at, we'll be able to do, and the table will just minorly help us, okay? So this is going to be undefined. This is going to be 0 plus 1, 2. It's going to be 2. This is going to be, oh wait, sorry. My apologies. This does not make sense. This is why you have to actually do the math. So x plus 1 equals 0. Then x can't equal -1. This is when you accidentally go too far over. And 0, 1, 2. Okay, that makes more sense. So 0 is 2. 1, if you plug into 1 here, it goes 1 plus 1 is 2. 2 over 2 is 1. and then this is going to be 2 plus 1. It's going to be 3, so it's going to be 2 over 3. Okay, this is going to be undefined because if you plug in -1 plus 1 is 0, so we can't have a 0 there. -2 is going to give us -2, -1, and -2 over 3. Now notice these 3 and these 3 are connected. Okay. Okay, so what's our graph going to look like? Wait, I didn't do the math right. People, don't trust your brain when you do it too quickly. Okay, I'm just erasing this for a second. Just erase this. Because my mistake, people, is I didn't take into account our vertical translation. Okay, so we have to do the whole map. So for this one, I did choose the right axis, though. I did choose the right axis, but my y's did not correlate with reality. So if your y's don't correlate with reality, that means you did something wrong. Okay, so I'm going to plug in 0. So let's do the process. So what we're going to get is we're going to get 2 over 1 minus 3. 2 over 1 gives us 2. 2 minus 3 is equal to -1. Okay, so this is -1. I'm going to plug in 1. So this is 2, so that's 1. 1 minus 3 is -2. Then plug in 2 here. We get 2 plus 1, that's 3. So 2 over 3 minus 3, which will give us -2 and 1/3. Okay, over here, we're going to practice more than one of these problems. Oof, cutting it close, but I can make it. Okay, -2, plug it in. We get -1, 2 over -1 is equal to -2. And then -2 minus 3 is -5. So this is -5. It's going to be -4. And it's going to be -3 and 2/3. Now, it's the same distance from the y value that is our center. Yes, I didn't use the -3. It was so sad. Depressing. I know. When I make that mistake, I'm like, why am I doing this? But it happens when you don't look carefully at your equation. Okay, so -1, -2, 3, -4, 1, 2. This is 1, 2, 3, 4, 5. Okay. -1, 2. Okay. Now, this -3 is our horizontal. So we have x equals -1. That's our vertical. And our horizontal is y equals -3. So we get a horizontal asymptote and our vertical asymptote. So if you ever make a mistake, double check where your asymptotes are and it will kind of clear up what mistake you made. So for me, I didn't use the right horizontal asymptote or vertical asymptote at different times, and it affects your graph. Okay, so 0 equals -1, 1 equals 2, and 2 equals -1, 2 and 1/3. So we're going to have this beautiful curve. Beautiful curve. And then this one, 2 will give us -5, 3 will give us -4, and this will give us So we'll get this beautiful curve right here. Okay? And it should look pretty symmetric on both sides. So, for the last one, for the most complicated ones, you really just have to graph. You don't have to show all the steps. Do we write the asymptotes? You know what? I think it would be a good idea. I think it's a good idea because in this crowd's class, it's going to come up quite a bit, and in my class in the future, or pre-calculus, you will run into it a few times. Okay? So let's just say, let's write the asymptotes. Why not keep track of the thing that keeps coming up? Okay? It is in the book, so it isn't just completely just my thing, but it is in the book. Okay, people. If you have questions on the homework, so I will finish up here. If you have questions on the homework, you may ask them. I'm going to post the homework here shortly, hopefully in the next 30 minutes. Very likely in the next 30 minutes. Do follow all the directions. You will only have, say 1, 2, 3, 4, 5, maybe, okay, we're going to have 6 graphing. I know that feels like a lot, but it's really important. Well, yeah, we'll do 6 graphing. 6 graphing. It's like a lot, but I will help you with these, okay? So I will give you extra time on them, so it won't be due Monday at 3 p.m., it will be Tuesday at 3 p.m. That gives you a full extra day to ask any questions you have, okay? So if you do have questions on Monday when we are doing the next section, feel free to ask them, okay? Okay? Thank you guys so much. I know graphing is not our favorite, but this is the last section of graphing, so we won't have to do any more graphing after this chapter. I know there are possible graphing, but I'm not going to do it. I am going to need to post the extra credit. Okay, the extra credit is just going to be an interesting thing, and it'll be a higher level. So if you want to impress people, you'll start seeing them. Okay. Okay. Thank you guys so much. Again, have a wonderful day, and I will see you guys on Monday. When 9 a.m. We are done. It is very short. Very short. Sorry, let's do this real quick. Why is it only 1 hour? Because, actually it's not 1 hour, it's 1 hour and 8 minutes. Thank you guys so much. I appreciate all of you. I will make sure to post the homework and make sure it's not too difficult. Okay, bye guys.